You look at the history of AI, the invention of the term was in the 1960s, and look how long it took to really get the big payoffs. There were smaller payoffs along the way, but the really big payoffs have only been realized in the last 10 years, roughly.
This is Deep, the show about the emerging deep technology that will change the world. Today, we're chatting with John Hennessy, former Stanford president, computer architecture trailblazer, co-founder of 2 semiconductor unicorns, and now chairman of the board of Alphabet, Google's parent company. As a Turing Award laureate for inventing the RISC chip design that powers nearly every smartphone, Hennessy also helped launch MIPS and Atheros, companies that helped contribute to modern computing. As Stanford University's 10th president, he grew the university's endowment threefold and seeded spinouts from Google to VMware, giving him a panoramic view of how ideas scale into industries. So how do you lead both a lab and a $1 trillion boardroom? What habits turn breakthrough science into world-changing company? And which leadership lessons still guide Google's moonshots?
This is Ben Kaplan and Dan Hoffer from Deep Venture Partners.
Our email address, as always, is deepshow@deepvp.com. And let's go deep. John, it's great to have you on the show. I would love your perspective of where we're at right now in terms of technological advancements. AI and machine learning is accelerating things incredibly. We are also at a moment where there's questions about research funding at universities. How would you describe this point in our technological evolution where we're at right now?
Well, it's a very good question. I would describe it as we are riding the wave of the breakthroughs that occurred in deep learning. Those were breakthroughs based on decades of research that had occurred almost exclusively in universities in the early stages, certainly. And we're riding that wave. And like other waves in the past, the invention of the microprocessor, the personal computer, the internet, it causes a whole transformation in how the industry works. I think we're also at an interesting time where universities are a bit under attack, and that should worry everybody who believes in this incredible ecosystem and U.S. leadership in technology and science, because that leadership is rooted and built on the universities and their ability to not only produce great research, but also train the next generation of innovators who are going to go out there and really carry these inventions forward.
How does the sort of reduction in potential funding from the federal government, how does it impact a Stanford where sometimes people say, well, you got a massive endowment, you have a lot of really wealthy alumni who are very famous, who can write big checks. Oh, Stanford's fine. How does it affect like a Stanford?
Well, the government is still one of the primary supporters of the research endeavors of the university. It is true the endowment is the big supporter of things like financial aid, and we give financial aid to more than half our students. Most graduate students, PhD students, are supported by a combination of either government funding, particularly in science, engineering, and medicine, or by university funding in disciplines in the humanities and the social sciences, for example. So there's a coming together of the two working together. But if I look at the engineering school, I mean, I take my own career. I spent most of my time working on research projects for DARPA, which really led to the VLSI revolution, the RISC breakthroughs, and various other the early stages of parallel processing, all financed by those research things. And they financed our research activities as well as our graduate students and our graduate student population that went out and now works in companies across Silicon Valley.
Are you seeing an impact of the budget cuts from Trump on Stanford across both physical sciences as well as life sciences, or is there a disproportionate impact in one or the other?
I'd say right now the bigger concern is around the life sciences, because there've been talks about direct implications for NIH funding, who is the primary funder of
National Institute of Health, right? That's just direct primary funder.
Yes, they are the big funder of biomedical research. So that's been the one that's been impacted most aggressively. But if indirect costs pay the lights, they pay for running the building, they pay for keeping the phones on, keeping the internet operational. So all the basic things that you need in order to build a research endeavor on top of get paid for those. If that rate is cut, that's going to affect everybody across the board. So there's a lot of uncertainty that is floating around, and we'll have to see where things settle out over time. But I worry that this is the first time that I can recall where we didn't have both sides of the aisle really committed to the basic research leadership of the United States. Look, we have the best universities in the world. There's not even a question about where the best universities of the world are. And that's been built over decades with a lot of federal investment as well as a lot of philanthropy. To lose that, that's losing the future. That's losing your leadership over the long term.
John, you're going to be appointed to do the right balance and mix between university research on one hand, also because you have a unique vantage point of chairman of Alphabet, and because Google DeepMind played a major role in advancements. And so there's corporate research, and then there's startup companies and others coming. So there's people coming now that are the OpenAI and XAI and all of those. What is the mix of what does each part of the ecosystem contribute if we have a well-functioning ecosystem?
Well, I think you said the key word, mix. It's a mix. They work on different time horizons. For the most part, companies think about relatively shorter time horizons. They may have a long-term goal in mind, right? They want to get to AGI. They all want to get to AGI. But they have a set of goals that are over the next 5 years that are about developing products. Universities are about getting the fundamental understanding that enables you to develop that product, right? I mean, when the AlexNet breakthrough occurred, that was university research. It preceded any real attempt to really think about how these things would be applied. And it was a turning point. These things occur, and then of course you had AlphaGo, and you had lots of other things that occurred after that really drove home the point that these deep learning techniques could really do the kinds of things that AI systems previously had not been able to do. But we need a mix, and the government is the supporter of basic research, because that's the kind of research that it's difficult to say what the short-term to medium-term financial impact is. The long-term financial impact is tremendous. It leads to a country which dominates in science and technology.
And John, maybe for the benefit of the listeners, you can briefly define AGI.
AGI is what we think of as the ultimate AI notion, right? And it artificial general intelligence, meaning an AI system that's not just good at one thing like image recognition or natural language interpretation, but can actually reason the way we are able to reason across multiple fields and multiple disciplines.
And I'm interested your perspective too, because really from your work, I mean, you sort of pioneered methods for making a reduced instruction set computer, sort of a microprocessor architecture that was more focused on a purpose to be more efficient. Given that vantage point, what is your perspective on DeepSeek, other attempts to sort of like say, hey, is all of this AI work and research actually could be made more efficient and doesn't have to be so expensive and doesn't need all this energy and resources? What is your perspective on that? As just you're someone who's sort of championed efficiency.
My perspective is it will be made more efficient, and we will find ways to improve this, particularly as we shift from, there's both a training component, right? That's the process of actually training the models and learning things. And then there's the inference part, right? I've got a model. Now I want to serve people using data that I've trained on. And the important thing to remember is you go through training once, right? And then the model is trained. You do some post-training and some user-trained functions there to kind of make the model adapted to a particular environment. And then, hopefully, millions of people will be using that model. And then in that inference thing, you've got to make that very efficient, because all of a sudden, you don't just have one user who's training it or a team that's training it. You've got millions of people using it. So we're going to have to get that to be more efficient overall. There's a lot of people focused on that. At the same time, it's sort of a race. You're trying to push the technology forward using whatever approach you can, including some brute force. At the same time, you're trying to improve the algorithms so that you can make them more efficient, make them more energy conscious in their thing, and that's going on at the same time. And you've got people designing new hardware to do this efficiently, right? So that all these things are going to work in parallel to achieve the kind of rate of progress we'd like to see.
What is the sort of perspective of sort of Google? Because it seems like Google was part of the core sort of effort to really do this. And then there's sort of these other players that come in last minute. How does it sort of feel at Google these days?
It's like I think in many ways, it's like other technology revolutions where people, you find a new discovery, there's a discontinuity, right? That's what the internet was. It's what the microprocessor was. It's what the personal computer was. They were discontinuities in how we thought about things. Same thing with deep learning. And every time there's a discontinuity, there'll be multiple players initially at the starting gate as that discontinuity became widely known. And they'll all be off racing, trying to do their thing and trying to find applications of their model to particularly important problems. And I think that's what we're seeing now. So we'll see this. Just as we saw this similar kind of thing happen with social media, right? And there was an explosion around social media.
Or heck, at one time there was Alta Vista and Lycos, and there was a whole bunch of things at the time, right? Yes.
Larry and Sergey found a better search algorithm. Fundamentally, they found a better search algorithm. And I used Alta Vista. It was great. And then the first time I tried Google, I said, my goodness, this is so much better. And you realize that kind of algorithm, which came out of fundamental research. They weren't even, when they first started working on it, they were working on library search, how to search libraries to find the best paper by Einstein, for example. And that led to insights that were then transferable to how do you search in the web, and a breakthrough in how we did search. So I think we'll see other kinds of breakthroughs like that occur.
And using your Alphabet business hat, if you evaluate various companies and you see them reducing R&D spend, how do you think about their prospects for the future? And the reason I ask is because effectively it seems like the budget cuts are reducing R&D spend of the country, of the United States. And so if we think of the United States as a company, if you reduce the R&D spend associated with the country, what are the longer term implications for the country?
Yeah, I think it's a very good question because, of course, the R&D expenditure being cut here are basically the fundamental research that goes on in universities, because that's what will be cut. It's a relatively small piece of the budget. After we pay for entitlement programs and we pay the interest on the debt and we pay for defense, the rest of the budget is about 12, 13% of the overall budget of the United States. And that covers everything. That covers all research. It covers road infrastructure. It covers everything else that goes on in that. So it's a relatively small piece. I think the real danger is if we reduce that piece, that will reduce the investment in long-term fundamental breakthrough kind of research. We won't know it next year or the year after. We'll know it 10 years from now. And we'll know it especially if countries around the world, particularly China, whose R&D investments are going up very sharp, very quickly. If they continue that, they'll pass us by eventually. There are already some indications in terms of patent filings that they have achieved at least parity with the United States.
And tactically, how does that manifest? Does that manifest in terms of PhD students or postdocs moving to China instead of the United States, or how does that actually get actualized?
I think we've already seen some impact in terms of a slowdown in students coming to the United States, particularly from China and India, which have always been two in the tech and STEM fields, always been a big supply. We've already seen some slowdown there. Long term, look, Silicon Valley is built on the ability to bring in the very best talent from around the United States, but from around the world as well. And you just have to walk through Silicon Valley to realize how much we've depended on that immigration of incredible talent. It would be a real mistake to turn that off, that source of expertise and talent. And in the long term, it will lead to the United States being in a second or third tier position over time.
Well, and how does it evolve, this sort of like collaboration versus competition globally? I mean, you see it in fields like, ones that we follow, like fusion. Right now, fusion is largely very collaborative. It's cooperative. People are sharing insights. They're trying to advance things forward. But at some point, this sort of pivots to competition, and it becomes, where are we, versus certainly China, but other allies too. France is doing a lot in fusion. There's other things. So how does this, are we at this competitive phase? Is there room for collaboration to advance sort of the field, all of mankind?
Yeah, it's a good question. I think there's certainly room for collaboration, particularly around really hard parts of the problem. And how do we ensure that the systems we build, for example, have the kinds of behaviors we'd really like to have, as opposed to negative behaviors? How do we think about dealing with issues of bias? How do we think about hallucination, right? So we don't build systems that hallucinate and get things that are irrational and potentially cause problems. I think if you think about deploying AI in defense, you better begin to have global conversations about what is going to be acceptable and what's not acceptable in that context. Otherwise, I think we will be in a really highly competitive and rather dangerous competitive situation. So there are a range of topics that are going to have to be discussed on the national stage. At the same time, obviously, we're going to compete, right? And that's a fact that you have to accept and realize that it has consequences.
You famously did a presentation, I think back in 2019, on the future of computing. And that presentation, you talked about the end of Moore's law, which says that the number of transistors on computer chips doubles approximately every 2 years. You talked about the need for domain-specific applications, the importance of sort of energy efficiency in this. What would you say now, if you were going to update your presentation on the future of computing, generally speaking? Where are we now? What is the future of computing?
So I think it largely what we said in that talk has happened. I think Moore's law is definitely slowing down with what's primarily happening is the time between generations is going up. Dennard scaling, which was this fundamental observation that you could shrink things down, get more components, but they would take no more energy, has ended. And chips now are they're totally energy limited in their design. So engineers have to think about that from the beginning. The good news is along came deep learning as a consumer of massive amounts of computing power. I mean, some people thought, well, it's not clear. Computers have to get a lot faster because what will we do with them? Well, along came deep learning, which can suck up more cycles than we ever dreamed of. The good news is that it's actually a rather structured computation. It's doing large-scale linear algebra. And we know a lot about how to optimize hardware for that. So you see what NVIDIA does or what Google does with TPUs, where they really design the hardware to be much more efficient. I mean, 100 times more efficient than if you tried to do it with an off-the-shelf CPU. So there's a big advantage that's gained by designing these things appropriately and by understanding that interface and then thinking about how to use it.
Your comment there about finding a need for computing power, it reminds me of, I think, the famous quote. I don't know if it's myth or if it's true. It's attributed to like the founder of Digital Equipment Corporation that there is no reason for any individual to have a computer in their home.
Yeah, he didn't believe in personal computers. People get things wrong. I mean, Watson once said about IBM, well, I think we'll sell 6 of these machines, right?
Strip a processor to its leanest instruction set, and you get more speed with less power draw. That less is more mantra, RISC, sparked the energy-efficient chips inside phones, smartwatches, and data center accelerators. Fewer instructions means shorter design cycles means faster innovation loops. Lower transistor counts means cooler chips means longer battery life. RISC wasn't just a technical tweak, it democratized chip design, letting startups challenge incumbents the way that PCs once challenged mainframes.
You've spent your career in academia, both as a professor on the administration side, but also, you've spun off 2 companies that you've been the co-founder of. I'm curious about your perspective on what makes a good company to spin out of a university. Should professors be become CEOs, or should they recruit other business people? What is your perspective? Because I know at least one of the companies I think you co-founded during your sabbatical year. What is your perspective on that whole ecosystem and universities as a source of companies?
I think was fundamental in both the companies that we spun out was we had a deep understanding of a new technology and a technology breakthrough that was really revolutionary. It's a good thing that technology was really great, because in the first company, we're 3 engineers that didn't know anything about running a business. And I mean anything. We didn't know how to put together a business plan. We didn't know what gross margin was. We didn't know anything about the things that I had to learn along the way. And it would have been much better had we worked with somebody with more of a business background early on. We went and we found somebody who was a great initial acting CEO that took us through the early stages and things. But we made a lot of mistakes because we didn't understand the business side adequately. We also had another hurdle, which I advise. We had to both invent a new technology and come up with a new business model. And I've recommended to people, don't invent a company that has to do both. New business models are fine. Companies eBay is a great company built out of a new business model, right? We're going to put auctions online and let people buy stuff online. Google is a great technology business model, focused on a new technology. Google had the great advantage that Yahoo had already proved that advertising could be the way to monetize on the internet. So it was pretty easy for Google to say, let's use search, we'll monetize search. Yeah, that sounds good. So doing both of those was really hard, and I learned that the first time around. Obviously, the second time around, I knew a lot more, and I could think about who to hire as a CEO, how to recruit the business side of the company. But young people, it's hard when you're a technologist to really understand that there are a bunch of things on that business side of the company that you really do need to understand and you really need experience with. And it makes a big difference.
Sometimes the technologists or the scientists or the inventors are very, very smart people. And they understand things that pretty much no one else can understand because they are that smart, but also they put in the time and they have the expertise and the base. And then to be like, oh, relatively trivial stuff. Oh, it's just a business plan. Oh, we just have some market. It seems like easy by comparison, but it requires some focus and some experience as well to have a successful venture.
Yeah. And the advice I give to lots of young people, if you ever want to think about that, first, go do some sales calls. Go do some sales calls and be in the sales call, not just an observer. Be a person doing the pitch, because you'll learn a lot about what it takes to convince a customer to come on board and use your product. Particularly a small startup, right? Big companies are very nervous about alliances with small startups. So it's a good process to go through.
And I'm curious, given some of the research funding cuts that we were discussing and the impact on the ecosystem, it seems like there's a gap being created and potentially an opportunity. But I'm curious, from your perspective, do you think that VCs or any other parties or types of entities will have an opportunity to fill the research funding gap that has been created, or step in some way, perhaps in a more involved way than they were previously?
It's unclear whether the venture capitalists will step in. I mean, there have been, for example, in the fusion area that you mentioned earlier, there have been some people who have put money into things which are really long-term. They are long-term investments, and to be successful. Now, if they're successful, it'll be great. I think they're, in many cases, motivated both by getting the return, but also by doing good for the planet and the environment in which we live. That's less true in most of the venture industry. It's not the way they approach it. So I think there are differences there. Whether or not philanthropy would play a bigger role in the future, it may well. I mean, it has in the biomedical area. You have things like Chang Zuckerberg and ARC and the Broad Institute, where private philanthropists are not covering the full cost of research, but paying a bigger piece of it than they have in other areas. So we may see more of that going forward. I think if you say you're going to pull the plug on the government side, that's a very big number. That's a very big number, bigger than the net worth of most of the philanthropists that would put money into it.
And obviously VCs don't typically fund, university level research, but at the same time, if the amount of time that innovations are being incubated underneath the auspices of a university is being reduced, then potentially, and I defer to you on this, whether VCs could or will step in to get involved a little bit earlier in the cycle.
I think that the observation, there are two very different sectors in if you think about technology spinouts. Most information technology spinouts, whether they be hardware or software, there's a proof of concept by the time you spin it out of the university. There's a demonstration that the basic insight is there, right? And now you've got to commercialize it, which normally means rebuilding it with commercial quality and standards about it. In the biomedical area, you don't really know that you've got an invention yet, something that's going to get to market, particularly in drug development. By the time you spin it out of the university, you've got an observation in a lab. You haven't even gotten through phase 1 clinical trial. So it's a very different process in that sense. In the first case, in information technology, time to market matters a lot. There's a window, and you have to be the best technology coming to the market within that window in order to win. In the drug development area, for example, you solve the problem. You solve Alzheimer's. Doesn't matter what it costs. If you solve it, there'll be money to pay for it. So you just have to be the first person to solve it. And so they operate differently in that context. We sometimes say in tech companies, when you're building it, will the dogs eat the dog food? In other words, if I build it, will they come? And, sometimes there are great successes, but there are also companies that build technology that at least looks attractive to the venture community, but doesn't really gather an audience and really go viral.
Well, and that's my concern too, is that, maybe the things that are, short or medium term horizon that requires dollars, maybe we can get some additional support. Maybe even corporations could come in and fund more research and other things, a little more. But like long term, that requires long term investment where anyone who's looking at this from a financial return perspective, it's difficult to justify the, large number of dollars over a long period of time. That's where I get concerned.
You are exactly right. I mean, you look at the history of AI. I mean, look, the invention of the term was in the 1960s, and look how long it took to really get the big payoffs. There were smaller payoffs along the way, but the really big payoffs have only been realized in the last 10 years, roughly. So it took a long time. Similarly, you mentioned fusion. Think how long people have been working on fusion to try to make the breakthrough. And many of the technologies go back decades now at this point in terms of, there are innovations, of course, but some of the core research goes back decades.
I watched the movie Oppenheimer again recently, and you see the Manhattan Project. And of course, what came out of the Manhattan Project was really the national laboratory system, right? This network of laboratories that will have, affiliations with different departments of the US government. Do we have to think about expanding something like that? Or what are the national laboratories? What's the role of that going to be in all of this?
Well, the national labs can do experimental work at a scale that no single university can do. And that's the kind of work they do, whether it's understanding the fundamental structure of the atom, work on fusion, work on deep UV, extreme UV, which really came out of the national labs and is now critical to the semiconductor industry. So there are lots of discoveries like that occur that only can occur with that infrastructure and investment that the national labs are the places that can afford to do it.
When you've written a book on leadership, you've seen that issue from multiple hats and perspectives. What makes a great leader, whether that's, a leader of a board of directors, a leader of a startup, a leader of an academic institution, what, in your opinion, makes a great leader who can move, people forward?
So I think, I think of great leadership beginning with a little bit of humility. And people say, why is humility critical? We have examples of people who are not very humble who seem to be doing okay.
Some current examples, yes. We won't name them, but some current examples, yes.
But for me, humility is a grounding thing in that it makes it very easy to say, I'm not the smartest person in the room about everything. I need the entire team to work together. And great leaders are people who really lead teams. They build a team that's collaborative and can work together and do something that they couldn't do as individuals. And so the job of the leader really is to inspire people to go to some place that looks hard. It looks really hard to get there and risky, but as a team, they can do it together. And that really begins with humility and collaboration and figuring out how to make that teamwork and being authentic with people. People like to know, you can say, this is going to be hard, but we can do this. We can get this job done. We can do something really marvelous. We can, and when in a startup company, that's what you have to have. You have to have that. And most startup companies I know have gone through a difficult time when things look really grim and it looks like it's going to collapse. That's the time when the leader has to get up and say, this is a great team. We have a great technology. We're going to do this, but we're going to have to double down and really work to really make it successful. And I think that's the mark of a great leader.
Who has really impressed you with your leadership? Because you saw a lot of, these kind of leaders of the major companies of Silicon Valley, major startups come through Stanford. You knew some of them, and then of course your career later. Like who impressed you in all of this?
The people I've known over the years have all been great leaders in different ways. Steve Jobs was fanatic about user interface, making this thing natural, making it really work. And he drove that in a way I've never seen anybody do it before. And of course, returned to Apple at a time when the company was really in trouble and turned it around. Eric Schmidt was the ideal leader to get Google started, the ideal person, because he was technical enough and he had the business acumen. And so he could work well with Larry and Sergey and really build the company into a really interesting combination. I think those people are going. The initial leaders of Intel were terrific people. I mean, Andy Grove and Bob Noyce and Gordon Moore are incredible, both technically very deep, but also great leaders. The classical example, I think, in Silicon Valley would be Bill Hewlett and Dave Packard. They invented many of the flattened organizations, get rid of the hierarchy, have offices out with the rest of the team. And I still remember the day when we dedicated the Gates Computer Science Building, and I got to introduce Bill Gates to Dave Packard and Bill Hewlett, who he had never met. And to have these two guys that started the real first startup in Silicon Valley in the 30s, right? Meet one of the later stage entrepreneurs that started the software entrepreneurship sector was really a great opportunity.
John Hennessy distills effective leadership into 10 practices. Among them, build a diverse team, embrace risk, and commit to lifelong learning. Consider Alphabet. In certain lab teams, leaders give teams tight goals and permission to kill projects that stall, turning failure into institutional muscle memory. For founders, here's the takeaway. Culture is a core competency. Engineer it as deliberately as you write code or design hardware.
You're, of course, mentioning all these other people. You're being a little bit maybe humility or humble yourself. I don't know of a single other person who walks around with the title, the Godfather of Silicon Valley. Do you have that on business cards? What is it to be the Godfather of Silicon Valley?
I mean, for me, coming to the Valley when I came at a time when the computer industry was just beginning to be established in the Valley. When I came, it was mostly semiconductors, right? And magnetic storage, actually. But to be at the beginning of that and a time when what was happening in integrated circuits just transformed the entire industry. And I remember the early days, I would have to get on a plane to fly back east to talk to the big honchos in computing because they were all back east. Now they come out to the West Coast to visit us. So it's a really interesting change that's occurred over time.
What is the future of Silicon Valley? I mean, we've certainly seen, more centers of innovation open up around the world. We've seen what used to be you had to be in Silicon Valley to get venture funding no longer necessarily be the case. What is the future of Silicon Valley and this entire ecosystem and technological roadmap?
Yeah, I mean, I think the Valley will continue to be healthy. It'll continue to be a source of innovation and creativity. After all, you have two of the greatest universities in the entire country located in the area, with Berkeley and Stanford. So it'll continue to have that. But the Valley also has limited carrying capacity. It has various infrastructure problems. So I think it's nice to see and think about getting other major technical centers built around the country. And I think that'll be a healthy thing for the country over time as well.
Was Stanford ever going to open up, wasn't that at one time a debate like Stanford, New York City?
We did an exploration of doing something in New York City, and the bureaucracy just became too complicated in the end.
And are there well-developed innovation pathways that are equally robust in other parts of the country and the world? Because obviously Stanford's very unique.
Yeah, they'll come over time. I think that's a very insightful question, because there are lots of pieces you have to put together. It's great, starting with great educational institutions as kind of research institutions as a source of new knowledge is important. But obviously you need investors, you need talented management pool. I mean, if you look at the history of the Valley, one of the things you can see is the management skill for these young startups often came from companies that had earlier times around. So Intel people, became the startups and next generation semiconductor people. The HP provided many of the people who helped start Sun, and then Sun provided many of the people that started the next company. So there's that kind of building up of talent base. That'll happen. That takes time. And you've got to make the environment attractive. One of the great things the Valley has is it's an attractive. People like to come from wherever they come around the world here. And you can find people who like the same kind of food that you do, or the same kind of entertainment. And that makes it a community that's very supportive of bringing in people from around the world and bringing in talent. Wherever anybody wants to build a major center of ecosystem to do innovation has to have that, because you've got to be able to bring in the talent.
It's an interesting confluence of sort of technical innovation talent. Of course, you need entrepreneurial talent, people who have vision, but then you also need, I guess, managerial talent as well, people who've been around the block, right? It's different to be an entrepreneur or a leader versus a manager. You need all of that to sort of mix together.
Mark Zuckerberg is brilliant, but he needed Sheryl Sandberg to get that company going and to get it really moving along, I think. And, Sheryl brought a set of experiences that Mark simply never had, right? So there's that marriage of capability that's really critical.
What lessons can we take from the world of technology that we can apply to other things?
So I think the lesson you have from technology is innovate to survive. If you don't innovate, and if you look at companies that have faded over time, it's because they failed to innovate. And the thing that the Silicon Valley reminds you of constantly is it's that new startup coming from below that's going to eat your lunch. It's not the big competitors out there, and you should remember that. But think about that new startup that innovates, that's going to bring out a new technology that's going to undermine the core technology. Now, we might ask ourselves, why can't we innovate in the way we govern and run the country as well as we've been able to do around technology? And maybe that'll be a challenge for future leadership in Washington.
Don't be evil was the slogan that Google was known for. How do we do this, and what is the future of all? Is can we do this without being evil? Can we innovate? Can we win? Can we compete? Can we do that?
It's a very good question. So I think, for Google, the trust relationship between Google and the billions of people that use it every day to do things is fundamentally important. And so we made a commitment early on that we would always provide what we think are the very best search results. And you can depend on that. And that trust relationship was really crucial. I think the trust relationship is going to be crucial going forward between technical companies and the users of their technology. And keeping that trust relationship is vital to keeping a positive relationship between technology companies and society.
And any other recommendations for operating a board of directors well? I mean, you're a non-executive member of the board. As I understand that probably means one of your primary functions is making sure board meetings run well and making sure that the board has an opportunity to make a meaningful contribution. What is your recommendation for other companies, those listening, investors listening too, that need a well-run board of directors?
I think the hardest thing to get on a board are directors who can add strategic value, who can challenge the team and get the management team to think about where they're going and to articulate their reasoning really well. There's a lot of pro forma things that boards have to do. Those are not the most important. Those are important, but they're not the hard thing. The harder thing is to really say, how do we bring an external perspective that's different than the management team might have and get them to think about things in an open and a progressive way? And that, I think, is the key thing that we try to add. Obviously, you need a management team that can work. You need a board that can work well with the management team. So how do you build that relationship that the board can challenge the management team, but the management team and the board are still on the same side of the equation?
John, it's been a pleasure to chat with you. I mean, what a career, what history from academia to multiple startups to, your contributions at Alphabet.
Thank you so much, John.
Thank you.
This episode has been brought to you by Deep Venture Partners, an emerging venture capital fund in Silicon Valley. Get show notes, transcripts, helpful links, and more at deepvp.com.